Okay, solving combination circuits part 2 or part 3, I don't know, part 2. We'll call it part 2. I've got another worksheet example up on the board that's posted on the Learning Hub. So this is a 4-element combination circuit. We've got 4 resistors, R1, R2, R3, R4, and we could examine the relationship between all of them. Very quickly you can look at the relationship between R2 and R3. They're in parallel with each other, okay? However, all of this is in series with R1 and R4. So if we wanted to simplify this out just simply down below, we could call this, or make this circuit into something like that. So that would be R1. This is the parallel or the reciprocal relationship of R2 and 3, okay? And then this is R4. All right? So solving one like this, if we gave some values, let's call them each 10 ohms. Okay? And I'm going to give a source voltage here of 50 volts. All right, so that's my E total. Now, we can simplify, or we have to simplify the parallel portion down in order to be able to come up with an R total to solve for a total current, which will then allow us to solve for the voltage drops and the powers at each of these components here. So we know we've got 10 ohms at each of these guys, because they don't change, but the relationship of R2 and R3 is a parallel. So that means we need to do the reciprocal of R2 plus the reciprocal of R3 and then get the reciprocal of that answer. So if we go 1 over 10 plus 1 over 10, reciprocal of that would give us 5 ohms. Okay? 10 plus the 5 plus the 10 gives us 25. So my R total for this circuit is 25 ohms. 50 divided by 25 will give me my line current here, which happens to be 2 amps. Okay? So I have 2 amps flowing through the series components and then back to the source. However, it's going to be doing something different here. This is where we can pay attention to the simplified version down here. If we take our 2 amps through all of this, okay, we can solve for voltage drops. Now our voltage drop at R1, 2 times 10, gives us 20 volts. Okay? 2 times 10 gives us another 20 volts. Okay? 2 times 5 will give us 10 volts here. That 10 volts will be at each of these. So V2 is equal to 10 volts and V3 is equal to 10 volts. Now utilizing that voltage drop and the resistance at that branch, we could then solve for the current. In this case, we've got 10 divided by 10, giving us 1 amp there and 1 amp here. If we've got 2 coming in, it's splitting equally. If these values were different, the amount of current would be dictated by the amount of resistance on each branch divided into the voltage at that branch. Okay? So that's a basic solve of that type of circuit. I'll do one more here, a different type. Your last worksheet.